Hi, I'm Bob Taybor with Developer University, and I welcome you to this course covering the fundamentals of the C# programming language and programming topics in general, designed specifically for absolute beginners to programming. However, if you are completely new to programming, and you're new to the C# programming language, and you're new to building applications on the Windows platform, then this perhaps is the best place for you to start. Not only will you and I work together to learn the syntax of C#, but I'm going to take the time to walk through everything that we do together. I'll explain what we're doing, but more importantly, I want to explain why we're doing it, the thought process behind it. I'm going to try to anticipate the questions you might have, anticipate the problems that you might run into as you're typing your very first lines of code into the code window, or as you're working through some of the exercises that we'll work through together. And over the years, I've incorporated the feedback from thousands of students, feedback and suggestions on how to improve the course. I've incorporated those in an effort to make sure that this is the very best effort that I can put forward to help you get your feet wet with C#. Now, I only make one real assumption as we begin this course, and that's that you already have some version and edition of Visual Studio already installed on your local computer, and you're ready to write your very first lines of code. Now, if you don't already have Visual Studio installed, then please, by all means, visit visualstudio.com, where you'll learn about the many free and commercial editions of Visual Studio that are available, what the differences are. Now, personally, I used Visual Studio 2015 Community Edition, one of the free versions of Visual Studio that are available on visualstudio.com. And I want to emphasize that you can use any edition and version of Visual Studio with these lessons. Now, there might be tiny user interface differences between what you see on my screen and what you see on your screen as you work through the videos. However, I'm not going to be focusing on any specific features of Visual Studio, so hopefully that won't prevent you from following along no matter what. There will be other courses on Microsoft Virtual Academy that will demonstrate the power of Visual Studio, all the features that Visual Studio has to offer, explaining the differences between editions and versions of Visual Studio. But I won't be focusing on that in this course. I'm going to focus specifically on the basics of the C# programming language itself, and what I will demonstrate will be true no matter which version or edition of Visual Studio that you choose to use. And that's great news, because as long as C# exists, these lessons should still be valid and useful to you no matter what. So to get the most out of this course or any course that you find online, you really should become an active learner, and that takes several different forms. First of all, you should attempt to follow along closely and do what I call getting your hands dirty in the code, actually writing the code that I'm writing on screen, you're writing it along with me. All right? There's no better way to learn how to code than actually write code yourself. It's like suggesting that somebody learn how to play the guitar without ever touching a guitar. You'd think, well, that's virtually impossible. Typing in the code yourself will give you insights that merely watching videos won't. So pause the video, rewind the video, rewatch portions of the videos as you need to. I'm going to make the code available for download, and you're welcome to it. And you can use that to compare the code that you write versus the code that I've written in the videos. But you really should be typing in everything on your own in your own local copy of Visual Studio running on your desktop. So also, don't rush through this course. If something doesn't make sense, again, pause the video, rewind the video, rewatch those portions that don't make complete sense at first. Sometimes a second or a third viewing, focusing more specifically on what's going on around the screen and on the words that I'm saying can help. Being an active learner also means that you're taking control of the process of learning. So if I say something or do something that doesn't completely make sense, by all means, find a second or a third resource that can help you. Maybe it's an article out on msdn.microsoft.com or other videos on Channel 9 or Microsoft Virtual Academy. But make sure you search out those resources that resonate well for you. If you're interested in an even more comprehensive version of this course, of a C# training course that covers a lot more ground and more depth, complete with dozens of coding challenges and over 30 hours of video instruction, then please visit my own website, devview.com, Developer University. You'll also find many other training courses that I've created designed specifically to help you become a professional C# developer someday. Furthermore, over time, as we go through this course and as I begin to field questions about it, I might add some study resources and additional free content related to the topics in the course that you're currently watching right now. So that's another reason to be sure to visit me at devview.com. Now, like I said earlier, if you're new to programming, I'm really excited for you. Learning to write applications is really one of my life's passions. It's extremely gratifying to breathe life into your imagination and watch your creations come to life and watch other people actually then use your applications. You're embarking on a really exciting journey that's immersive, it's personally and professionally rewarding, and best of all, I know you can do this. Again, I've seen so many people start off where you're at right now, and they might even be working professionally writing code for a living or building real applications that are being sold in app stores like the Windows Store. So if you've ever gotten stuck in the past in trying to learn how to program, I promise you that if you put in the time and you put in the effort and you work along with me, as we work together, we're going to build the knowledge of C# that you need to be well equipped to move on to more advanced tutorials where you can learn how to build your own web applications and Windows applications, Windows Store applications, cloud services, video games, and even applications that will run on iOS and Android using C#. Now, assuming, again, that you have some version and edition of Visual Studio already installed and you're ready to go, then we're going to begin writing C# in the very next lesson. I hope you're excited because I really am. This is so much fun. Let's go ahead and get started. We'll see you there. Thank you.
Let's take a look at how to install Visual Studio using the custom option. For this example, we'll use the Community Edition of Visual Studio 2015. In order to get it, simply visit visualstudio.com and click on the Download Community 2015 button. Once we've clicked on the download, it'll download to our computer, and it's a web installer, so we click on the Run button and it will initiate the installation routine for Visual Studio Community 2015. Once we have the options screen available, it's time to start looking at customizing the installation of Visual Studio. For the most part, the default allows you to create web and desktop type applications. But if you want to create different styles of applications or include more languages, then the custom option is what you should be choosing. I always recommend selecting the custom option for the installation of Visual Studio 2015 to ensure that you're getting the packages and libraries that you need to create the applications you may wish to use. So by selecting Custom and clicking on the Next button, we are now brought to the screen where we can select the different features. The first option is Programming Languages. And if we click the arrow to expand it, we can see that we have Visual C++, Visual F#, and the Python tools for Visual Studio that are additional programming languages that will get installed if you select this option. Remember, by default, Visual Studio Community Edition will only install C# and Visual Basic templates. Also notice under Visual C++, we have options for the common tools, the Microsoft Foundation classes, and in Windows XP support for C++. For my purposes, I like to have all of my programming languages available to me because I create projects using the different languages all the time. So I'm going to select the checkbox next to Programming Languages to install all of those programming types. Also under Windows and Web Development, we can choose various options here for things such as the ClickOnce Publishing Tools, SQL Server Data Tools, PowerShell Tools for Visual Studio, Silverlight Development, etc. Here's a very important component. If you want to develop universal Windows applications, we need to ensure that we have the tools, the emulators, and the SDK. Now, you can choose the default install of Visual Studio, and then come back and install the Windows 10 SDK at a later time, and that will include the tools, the SDKs, and emulators for you. But it's so much easier to install these during the installation of Visual Studio. Please note that it will increase the install size of the application, so the tool set will be much larger. So again, depending on what it is that you want to do, you may want to select Universal Windows App Development Toolkit, PowerShell tool for Windows, or for Visual Studio rather, if you want to be using PowerShell tools within your applications. If you need backward compatibility for Windows 8.1 and Windows Phone 8.0 and 8.1, you can select this option. Also, there are some common tools or cross-platform mobile development tools. These are important if you want to develop applications using the Xamarin platform. Xamarin is a cross-platform tool that allows you to create applications for Windows Phone, for iOS devices, and for Android devices by using the C# language in Visual Studio. All of these tools are available for the cross-platform mobile development using Xamarin platform. It includes all of the emulators as well. So again, remember, it will increase the size of the install base for Visual Studio. You might also notice that because I selected the cross-platform mobile development tools, we now have a little box inside the Windows 8.1 and Windows Phone tools. If we expand that, we'll see that it has included tools and Windows SDKs. And the reason it does that is because there's a potential that you may want to target the Windows Phone 8.0 or 8.1 applications. So the tools and SDKs will also get installed. At the same time, the Common Tools checkbox includes a little square box indicating that we have also added another component here, and that is the Git for Windows. So we can install Git, which is your source control, GitHub extension to Visual Studio so that you can integrate with GitHub source control projects, and then of course an Extensibility Tools Update 3 for Visual Studio as well. You'll notice that by selecting all of these options, setup can require up to 48 gigabytes across all of the drives that will install it on. So again, review each of the items that you have selected to ensure you have all of the necessary components, tools, and SDKs for your development tools of choice or platforms of choice, and then select the next button. Once you do, you basically see a quick little selected features screen that will tell you all of the different items that you have selected, and by clicking install you agree to the license terms of all the software components. If you're not sure what those are, each one of the items that has license terms allows you to click on it to view those. Once you're satisfied with it, click the install button and Visual Studio starts installing all of the components that you have selected. So this is a quick overview of how to perform a custom installation of Visual Studio 2015.
Hi, I'm Bob Taybor with Developer University. For more of my training videos for beginners, please visit me at devview.com. In this lesson, I want to build a super simple C# application. I want you to follow along. It's a Hello World application, meaning that we're merely going to print out the words Hello World to a console window. And the point of this exercise is just to show you the basic workflow. So I'm not going to attempt to even explain why we're doing what we're doing. The focus will be on what I'm going to do next and how I'm doing it. In other words, I want you to focus on the basic workflow. That'll be the same for all the applications we'll build in this course and pretty much every application you'll ever build using C#. Things like how to create a new project. Where do you type in your C# code? How do you test your application to make sure that it's running correctly? And what do you do whenever you have an error in your code? How do you save your project? Things of that nature. So for now, just try to follow along. Don't worry if something doesn't make a lot of sense at this point. That's really what the rest of this course is for. In the next few lessons after this one, we're going to dissect this tiny little application that we built, and I'm going to explain at that point why we did what we did, and then what does the code mean and why it's doing what it's doing. And just a quick reminder, like I said in the previous video, the introduction of this course, I'm going to assume that you have some version and some edition of Visual Studio already installed Even if your Visual Studio looks a little bit different than mine does on camera here, don't be overly concerned about that. The basics are the same no matter what, I promise. All right, so let's go ahead and get started here. And to begin, we're going to create a new project. There are a number of different ways to do this, but I'm going to keep it simple and go to File, New, Project. And selecting that menu option will open up the New Project dialog. Now, chances are the number of items that you see here in this center part will be dramatically different than the items that I see based on which version and edition of Visual Studio that you have installed. However, you should be able to select templates and then select C#, and one of the options should be a console application. All right, so I want you to select that, and then we're going to rename this project to Hello World. Now notice I used a little naming convention where I use a capital H in Hello and a capital W in World, and I don't use a space in between the two words. Now that's just a naming convention that I came up with to help me identify projects a little bit easier, something I recommend that you follow. We shouldn't have to make any other changes in this dialog. I'm going to go ahead and click the OK button, and Visual Studio will go off and now create the starting point of a console window application for us. All right, and so now you should see in this main area, in this text area, a file open called program.cs, and there's some code here that is already generated for us, boilerplate code. We're going to ignore most of that, except we're going to find this innermost set of curly braces. Now, one of the first things you're going to need to do when you're learning how to develop software is tell the difference between parentheses, curly braces, square brackets, angle brackets, and I don't know that I left out any, okay? But here we want the curly braces, look like little mustaches turned on their side. These are important. And I want to go inside of those two, that opening and closing curly brace, and make some room for ourselves. This is where we're going to type our code. So it's approximately line 13 and 14, at least in my copy of Visual Studio. And then I'm going to type in the following. I type in console, and you may notice now this little window pops up below what I'm typing. You can safely ignore that for now. Eventually this becomes our best friend, but for now it might kind of be distracting and get in the way. Just try to ignore it and type in everything by hand to the best of your ability. Console, and then I want to use the period on the keyboard. I'm going to call it the dot. So console dot, and then capital W, right, capital L, line. Next, I'm going to use an opening and closing parentheses. So that's not a curly brace. These are just the like the characters you would use for a smiley face in an emoticon, okay? And then inside of there, I'm going to use the arrow keys on my keyboard to kind of navigate around here. I'm going to go inside of the opening and closing parenthesis, and I'm going to use two double quotes, so it should look like that. All right, make sure you don't use single quotation marks like that. That's not what we want. We want double quotation marks like that, okay? And inside of there, we're going to type in the words hello and world. All right, so make sure that you have an open parenthesis, a double quote, the words hello world, then another double quote, then another parenthesis, a closing parenthesis, and then at the very end of this line I'm going to use a semicolon, and it looks like that. All right, so it's not a colon and it's not a comma. All right, it looks like that. All right, and then I'm going to use the enter key on my keyboard to go to the next line. I'm going to type in console dot capital read capital L in line opening and closing parenthesis. Now you may have noticed that as you type in the opening parenthesis, that Visual Studio will automatically type in a closing one for you. Don't let that throw you. You can continue just to type through that, but make sure that you have exactly what I've typed into my code window here for these two lines of code. Make sure that the capitalization is correct. Make sure that you're using a period, not a comma, for the little mark that comes after the word console. Make sure you're using parentheses and not some other type of bracket or brace, and then make sure that both lines of code end with a semicolon. All right. So the next thing that I want to do is save my project. So I'm going to go, and there are a number of different ways to do this in Visual Studio. Again, I'm going to keep it simple and go to File, Save All. All right. And then the next thing I want to do is now see my application actually running. And so to do that, I can either find this little green arrow, this little green triangle that has the word start next to it, or if I don't see that, by default in my little toolbar here at the top, I can go to debug and select start debugging. Either way should work. I'm going to go ahead and click that, and you'll notice that some windows pop up and Visual Studio changes its appearance a little bit. Now off to the side of my screen, the console window popped up and we see the words Hello World with a blinking cursor below it. I'm just going to hit the Enter key on my keyboard, and then the console window disappears and I'm back into Visual Studio, kind of resets itself, and we're successful, right? However, maybe your experience wasn't successful. Maybe you saw an error message. So what I want to do is take a moment and look at some common errors that people that are new to C# might run into and how to remedy them. And this is a good opportunity to learn some of the syntax rules of C# as we make mistakes. Okay, so I'm going to pause the video, make a mistake, and then we'll talk about it, pause it, and so on. Alright, so when you attempted to start the application, you may have seen a little dialog pop up from Visual Studio that says there were build errors. Would you like to continue and run the last successful build? Always select no for that, okay? And what you'll see next is a list of errors. Now, in some cases, the error messages will be obvious to you and they'll make a lot of sense. Sometimes they won't, like the verbiage might be something we're just not familiar with yet. Invalid token in class struct or interface, what does that mean? Okay, so typically what you can just do is double click on these and it'll put your mouse cursor on the line where the problem is. Notice that Visual Studio also gives you another visual way to tell that there's a problem with your code. It gives you this little red squiggly line. Sometimes you'll see a blue squiggly line. They're a little bit different, but essentially this is an area of the code that probably deserves your attention, something you need to fix. Now in this particular case, the problem is that we didn't type our code in between the innermost opening and closing curly braces. And so this is an issue with regards to defining a code block in C# or a block of code. So different C# commands belong in different kinds of code blocks. And I'm going to spend a lot of time in this course talking about the different types of code blocks and what belongs in each type of code block. But to remedy this issue, what you need to do, use your mouse and just kind of drag and highlight these two lines, or you can use the Shift key on your keyboard and the arrow keys to kind of highlight that area, hit Control X, then move up in between the opening and closing curly brace and paste Control V, that code in there, and then it should run correctly at that point. All right. So that teaches us the first thing about C#. It matters where we type our code. All right. Or when you try to run the application, you may have seen the same build error dialog, except you see the message semicolon expected. Hopefully this is an obvious remedy for you. If you double click on that error in the error list, it should take you to the end of the line of code where you forgot to add a semicolon. And so that's the second thing about C# that we're going to learn, is that just like a properly formed English sentence has to end with a period or a question mark or an exclamation mark, a properly formed instruction in C# has to end with a semicolon. All right? Or maybe the error that you saw was something like a syntax error, something expected, the name hello doesn't exist in the current context, the name world doesn't exist in the current context. If you were to double click these, you'll get to the vicinity of the problem, and you'll also see that there's red squiggly lines beneath the words hello and world in between of our parentheses. Now remember, we needed to use double quotation marks around that string of characters, hello world. And so alphanumeric characters that we want to literally write to screen or present in some way, we need to surround them with characters that indicate that we want to use this literal string, the string of literal characters. Okay, so to do that we use double quotes. Or perhaps you see the error, something like, the name console does not exist in the current context. And you're like, it doesn't exist in the current context. You look at the word and you say, well, it looks spelled correctly. Remember that I told you you had to type exactly what I was typing, and so C# is case sensitive, meaning that a lowercase c and an uppercase C mean that you're typing two completely different things into C#. Okay, and that is tricky because many of us are not used to that degree of precision whenever we're communicating. But when communicating with a computer, you have to be precise. So in this case, all we needed to do was change the capitalization of the word console, and we're back in business. Or perhaps you see something like console does not contain a definition for either write line or read line, and again you're looking at it and you're thinking it's spelled correctly. Well, what could the problem be? Here again, capitalization is important. Lowercase r read line is different than uppercase r read line, and lowercase l read line is different than uppercase L read line. Okay, and so again, things have to be spelled correctly and have the correct capitalization in order to be processed correctly by the C# compiler. We'll talk about compilation in the next lesson. Now, fortunately, if you're not good at spelling and you're not good at typing and capitalization and you're just not as precise in the way that you would type a letter or an email message or even a text message, fortunately, Visual Studio can help you out. There are tools that will help you not only write your code more quickly, but also more accurately. And chances are, if you utilize those tools, the chances that you will miss some of these really simple syntax things like capitalization will almost be completely eliminated. We'll talk about some of those tools in an upcoming lesson. All right, but assuming that you got all of this to work correctly, you're really well on your way to building applications. You've already crossed over one of the big first steps. And as you undoubtedly learned in this lesson, writing C# code is an exercise in being precise, in precision. And again, fortunately, the Visual Studio IDE will help you out a lot when it comes to that. It will give you clues, and maybe some of the phrases and the words that they use to explain the issue might not be familiar to you yet. With experience, it will be. But generally, it'll point you into the right direction, and with the red squiggly lines in the message, you can typically figure out what the issue is. Now, throughout this course, if you run into a wall and you simply can't figure out what the problem is, do this. Compare character by character. Take your time until you kind of develop a vision for the problems where your eye will jump to the problem in code. Compare what you wrote versus what I wrote. I'll supply the source code to you, and so open it up in a second copy of Visual Studio and then just look character by character. What did I do different than what Bob did? All right, and that will usually help you figure things out if you can't do it on your own. All right, so in the following lessons, we're going to focus on two things. First of all, we're going to talk about why we did what we did and what was going on behind the scenes that turned our code into a working application, albeit a small application. What happens whenever we create a new project? What happens whenever we choose to save our project? What happens whenever we choose to start or run our application? And then secondly, we're going to talk about the syntax of the C# code that we wrote, and we'll learn more syntax rules and more keywords as we go along. So if precision is so very important in C#, then you're going to need to have some explanation as to what all those little words and symbols actually mean and some rules to guide you as you're writing your own code. It's really easy once you get a few of the basics under your belt. Being completely honest, many people learn how to code, how to write code, and C# is a fairly easy language to learn. You can do this. Just you got to put in a little bit of time, a little bit of effort to figure it out. All right? So we'll begin that process in the very next lesson. We'll see you there. Thanks. Hi, I'm Bob Taybor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Now in this lesson we want to start the process of dissecting that little application that we wrote in the previous lesson. Now previously I wanted you to focus on the workflow, what we did and how we did it. But now what I want to do is focus on why we did what we did. It's really crucial at this point that we cement some really important ideas in your mind because they're going to provide the basis, the foundation for everything that comes next. So what I want to do is start on the inside and kind of work our way out. And I'll start by talking about the nature of writing code. When you learn how to write applications with C#, really any programming language, learning the syntax of C#, or in other words, learning the nouns and the verbs and the punctuation of the programming language is really just half the battle. The other half of the battle is learning about related pre-built functionality that's available to the code that you write. Now in our case, Microsoft has created something called the .NET Framework, which sounds kind of spooky and mysterious, but it's really not that bad. It's actually pretty large, but we're only going to focus on two specific portions of it for our purposes. The first part that I want to focus on is something called the class library, which is simply just a library of code that Microsoft wrote to take care of difficult tasks so that we as software developers, we don't have to worry about them. So there's library code to help with many common sorts of things that many applications will need. Things like working with math or working with strings and text and working with dates, manipulating dates and times, maybe displaying things to the computer screen or transmitting information across a network. So a lot of that kind of foundational stuff that would be difficult for us to write and is utilized by many different applications. So that's really the first part. It's taking advantage and understanding the class library of the .NET Framework. The second part of the .NET Framework is called the runtime. It's also known as the Common Language Runtime. You'll see it called as the CLR as well. And really it's just this protective bubble that wraps around your application. Your application lives inside of it. It runs inside of that protective bubble. And it essentially takes care of a lot of the low-level details so that you, the software developer, you can focus on what your application is supposed to do, not worry so much about how it's actually accomplishing it under the hood. You don't have to worry about the computer's operating system interacting with it and interacting with memory and interacting with, the hardware, the computer itself. Many of those things are kind of abstracted away from you. You don't have to worry about them. Furthermore, the CLR, that runtime, also provides a layer of protection for the end user, so that you, the malicious, evil software developer, you can't do something really bad to somebody's computer without them at least giving you permission to do it in the first place. So without their knowledge and their approval, you're not going to be able to wipe out their entire hard drive, for example. For right now, it's the .NET Framework class library that I really want to focus on because it's what we used, whether you realize it or not, whenever we were writing our first application. So, for example, in lines 13 and 14, where we did our work, you see console.writeLine, and then we used open parenthesis, close parenthesis, and so on. We were using code in the framework class library that knows how to display text into a console window. All we got to do is say, hey, use this text, stick it in a window. And we don't really care how it does its job. We just care that it did it. Okay. And so the next line of code, this console.readLine, it was also really important. We're telling the application to wait for input from the end user before continuing its execution. So again, here we're calling code in the .NET Framework class library that knows how to accept user input. You recall that I used the enter key on the keyboard, and then the application continued on, it exited, and we were back into Visual Studio. So in both of those lines of code, we were utilizing methods that were defined, that were created by somebody at Microsoft to handle that interaction with displaying and retrieving data from the end user. So what were to happen if we were to comment out that line of code? And here, to comment out a line of code, I use 2 forward slashes on my computer. It's over the question mark. And commenting out code simply means that I want those instructions to be ignored. Now, I could have just deleted that line of code completely, but I might want it later. So maybe I don't want to remove it completely. I just want to ignore it for now. Okay. I also might use code comments to write myself some notes to remind myself of something about the application in the future. We'll talk about code comments a little bit later. But if we were to run the application now, watch what happens. Okay, it ran and it's already done. What happened? Well, you might have seen a flicker on screen for like a fraction of a second. The reason was because, hey, it executed this one line of code and it said, well, looks like I'm done here, and it exits out of the application. By adding the read line, we're now stopping execution, waiting for the end user to do something before exiting out. Okay, so hopefully that makes sense. All right, so next let's talk about the position of the code that we wrote. I made sure to emphasize that you have to write the code in the correct place, and the correct place was in between the opening and closing curly braces of that innermost set of curly braces, as defined kind of by the level of indentation that we saw in the boilerplate code. So if you don't add the code there, we saw what the ramification of that was, right? The application, you'll try to run it, it'll give you a runtime error. The correct place for that code was where we have it right now, in between that opening and closing curly brace that you see on screen. Now, as you can see, there's several sets of curly braces, and so it's important that we talk about what these do. And I need to oversimplify things here. We will come back and fill in some of the details later. But essentially, you have an opening and closing set of curly braces, and those define a code block. And code blocks typically have names, and they have purposes. So in this particular case, we have a first code block, and this code block has the name main. Okay, and this particular code block is known as a method, and this particular method, by convention, is the very first method that's called whenever your application is executed. All right, and so I don't want you to worry about these other words, static and void, and even the string and the args for right now. We'll talk about those later on. But this entire code block here, as well as the line above it, they define something called a method. And a method is simply a block of code that has a name. Now later on, you're going to come to realize that a method is so much more than that, but I want to use that as a working definition as we're getting started here. The method has a name, and when you have a name, you can call a name and say, I want you to execute. All right. And so we'll talk about methods again a little bit more in a little while. This main method lives inside of another set of curly braces, and that set of curly braces also have a name. The name is program. It's a class called program. And so you can think of a class as simply a container for all of the methods of your application. You can kind of keep the methods that are related to each other in separate classes. Now, what do I mean by related to each other? Well, that's really for you, the developer, to decide. As you get deeper into programming, you're going to come to understand the thought process behind organizing your code. But that's a little ways off for now. Just trust me on that. Now, I said that a class was merely a way to organize your methods. It is so much more than that. And again, I'm way oversimplifying this as we're getting started here. But the main takeaway for right now is that that code is organized in curly brace containers, and you have some blocks of code that reside inside of other blocks of code. And to kind of emphasize that again, here we have another set of curly braces, and this set of curly braces has a name as well. In fact, it's a namespace called Hello World, which happens to be the name of the application that we gave it. Again, keep things extremely simple here. A namespace is just another way of organizing code. Again, at some point it becomes so much more than that, but let's keep it simple for now. So let's take a look at these lines of code and kind of illustrate these ideas about namespaces that contain classes that contain methods. Here what we're doing whenever we're calling console.writeLine is we're actually making a call into the .NET Framework class library. Remember, it's that library of code supplied by Microsoft, and we're saying in that entire library there's a book, and there's a chapter inside of that book that I want to reference. All right. So in this case, we're saying that book is the console book, the class, and I want you to look at the chapter named WriteLine that has the definition for this method. All right. Hopefully that analogy works for you. But we're looking inside of a library to find a class, and we're going to call a particular method inside of that class. And by using its name, we can execute all the code that was written inside of that method. Same with the method that we're calling below it as well. Notice that there is a period that we use between the name of the class and the method name, and we use that. It's called a member accessor. It allows us to access a member of the class, or in other words, now that we know what the book is, we can find out what chapter we want to reference. Okay, hopefully that analogy works for you. Now notice also that both, whenever we call the WriteLine method and the readLine method, that they both have parentheses following them. Now, in the case of the WriteLine method, we're actually sticking something in between the opening and closing parentheses, whereas in the readLine method, we're not. But essentially, those parentheses are saying not only do we want to reference that particular class method name, but the parentheses mean I want you to actually invoke it, execute it, do it now. Okay, so that's the purpose for those parentheses. Now, we can say do it now and pass in information. Do it now with this stuff, with this argument. So we're passing in an argument to the WriteLine method and saying, we want you to do it, write this to screen, and here's what we want you to write. So it's an input parameter to the method named WriteLine. Okay. Now don't worry, we're going to come back to the notion of methods in the future, as well as passing values into a method like we did as we passed in the literal string hello world into our method here. Just know that whenever you see parentheses after a given word in your code, you should be thinking that that code is being called right now as we step through the execution of the code. Next up, let's talk about the semicolon. We've already kind of explained it in the previous video, but just to kind of emphasize it, notice that almost everything, even these statements at the very top, have semicolons, with the exception of whenever we're defining a namespace, a class, or a method. And we said at the time that the semicolons are actually similar to the period or exclamation mark or question mark at the end of an English sentence. It completes a thought in C#. Now, some programming languages, like Visual Basic, for example, they don't really have this idea. They only allow one complete thought per line of code. However, with C#, you could do this, what I'm about to do. Watch. Okay, now I have both of those lines of code on a single line. All right, and if we run the application, it'll work just as it did before. All right, so the way that you separate or indicate that you have two different complete thoughts is through the use of a semicolon. Furthermore, we could put lines of code on separate lines like this. Now, it wouldn't make sense in this case because the line of code is so short. It actually makes it difficult to read, but sometimes when you have a very, 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 very long line of code, you'll see me split that line of code into multiple lines. and still the application will execute. Now, in other programming languages, you wouldn't have that behavior, all right? Because really, white space and line feeds and things of that nature, they don't matter to C#. The only thing that really matters is to indicate a complete thought is a semicolon at the end of the line. Let me go ahead and get rid of all that. And the other thing that I want to mention here that you may have noticed is the level of indentation that you get automatically from Visual Studio. Now that's completely optional, and Visual Studio nudges you in the right direction, but essentially, even if you were to kind of come out here, and we'll use the tab key several times and write the word console.writeLine, something like that, and notice that Visual Studio re-indented it for us. Why do you suppose it did that? Well, many people believe that indentation helps the readability of the code so that you can see what code container, where code resides inside of the other curly braces inside of your application. All right. And so kind of along those same lines, for readability's sake, notice that there are many different colors that are used as text inside of this text editor window. You have these royal blue colors, and these are my default colors. Yours might look a little bit different, but by default, I think you have some royal blue, some black, you have aqua color here. This is a dark red. You have some light gray and light blue. All right, and all of those are used to help you identify the parts of speech, I guess you can say, inside of the code that you write. All right, we'll talk more about that as we talk more about the syntax of C# in an upcoming lesson. Okay. All right, so now that we've talked about the code that we wrote and its position and formatting and white space and tabs and all that sort of stuff, what I want to do is stop right now for this video, and in the next one I want to talk about the files themselves, the file that we typed our code into, how that relates to projects and even solutions, what happened when we saved our project, what happened when we actually ran our project, and so we'll do that in the very next lesson. We'll see you there. Thanks. Hi, I'm Bob Taybor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Next, we're going to talk about how code files are organized into projects and solutions, and then where you can actually find these projects and solutions on your hard drive. So whenever we created a new console project, the program.cs file was opened for us automatically in the main area in Visual Studio. And that's one of the things that project templates do for us. Whenever we choose File, New Project, and we see the New Project dialog, and we choose a project template, they provide a great starting point for the type of application that we want to build. It includes files with boilerplate code, important settings, and other resources that we might need whenever we're building that type of application. So as you can see, we're working inside of this file in the main area, and there's a series of tabs. Again, this isn't intended to be an overview of Visual Studio, but it's important to note that the names of the code files that you're working on are contained inside of those tabs. And if you take a look over to the right-hand side, here is the Solution Explorer window, and it has a tree-like structure of all the items that are kind of contained inside of our project. Now, again, as I said at the outset of this course, this isn't intended to provide a tour of Visual Studio per se, and there are other resources on Microsoft Virtual Academy that can really help orient you to using Visual Studio and the various windows and functionality that it contains. But the Solution Explorer is probably the most important part of Visual Studio next to this main area where you'll usually see the text editor and other designer windows. So simply put, the Solution Explorer is our main navigational device to the other files and settings that comprise our program. So you can see here that there is a program.cs file. Now if I were to close the program.cs tab in the main area, I can always get back to it and open it up again by double-clicking it inside the Solution Explorer. All right, you can see it's open once again. Now files and important settings are organized into a concept called projects. So you can see here this word hello world is actually a project. You can see there's a little C# icon next to it letting us know that this is a C# project specifically. And projects get compiled into a single .NET assembly, which we'll talk about later. Furthermore, one or more projects are organized into solutions, and you can see in the Solution Explorer we have one solution here at the very top, solution also named Hello World, that contains one project. Now, in many cases as you're getting started, you're only going to have one project inside of one solution. But as you come to build more complex applications over time, it's highly likely that you're going to need to manage multiple projects that are somehow related. Now again, the reason might not be obvious at this point, but as you continue to learn C# and how to build more complex applications for large companies or for yourself, this becomes a crucial code management strategy. But just for now, accept the fact that there's this extra layer of a solution, and one solution can contain one or more projects, and the projects will contain then all of the code files and the settings and the like that will be used to create an actual executable program. So trust me, these concepts will become more important after we get past the basics. Now the big question at this point should be, where are all these projects and solutions and files actually stored on your hard drive? I mean, can we see them? We can see them in the Solution Explorer. Where are they actually on your hard drive? Well, when we created this Hello World project, we merely provided the name of the project, you'll recall, and then I said go ahead and accept the other defaults. By default, Visual Studio will put your projects into your Documents folder. So if you take a look here and we navigate into the Documents folder, it will put your projects into whatever version of Visual Studio you're currently using. So you can say I have side-by-side Visual Studio 2013 and 2015. We're using 2015 for this series, but it could be a future version of Visual Studio. You'll look in that particular folder for your version of Visual Studio. And as we drill in, there will be a projects folder, and as you drill in you can see that by default when we created our new project it put it here in our document/Visual Studio whatever version /projects folder. Okay, so as I add more projects, this obviously will be filled up with folder names for those projects. And it's important to note that whenever you create a new project, you don't have to create it and put it right here. You can put it anywhere. And so to keep things organized, you're typically going to keep them in the same place. Now, furthermore, you can actually open up a project that's saved anywhere on your computer as well. So, for example, I have this, in this course, I'll supply the projects. After I record the video, I'll zip them up and you'll be able to download them and then open them up on your own hard drive and then walk through them and to better understand them. And so just to kind of demonstrate how you do this, I have this project called, is zipped up into a file called example.zip. And so what I'm going to do is actually right-click this and select Extract All, and then in the Extract Compress Zip folders, I'm just going to put this on my root, so C:/example, and then click Extract. And so now you can see that on my local hard drive I have an example folder, and inside of that folder there is another folder with a file called example.sln. I'll talk about that in just a moment. But I can either double click this .sln file to open up the solution inside of Visual Studio, like so. All right, or I could go to File, Open, Project Solution, and then navigate to that directory using the Open Project dialog, if it'll let me. Okay. All right, and unfortunately it's a little bit too large for the recording area, but then I would just simply select the solution that I wanted to open from this dialog and then click the open button. All right, let's go ahead and close that. And let's shut down this copy of Visual Studio. And I want to get back to where we were just a moment ago in our Documents, Visual Studio, in my case, Visual Studio 2015 Projects folder. And here are a list of all the solutions in our project folder. And so just kind of want to walk our way through this. This first folder here will contain our solution files. So there's this .sln file, which is a solution file. It contains information about all the projects that are under this umbrella solution. Okay, and we could actually open this up and look at it inside of Notepad, and it's simply just a configuration file. There's nothing all that special about it. You certainly don't want to make any changes to it, but it's going to have information about all of the locations for the various projects that are associated with this solution. Any global settings and some of these things won't really be useful to us until we get deeper into our understanding of compilation and things of that nature. But inside of the solution folder is a second folder which is actually going to contain the project files. And so here we have a hello world.csproj, which is a project file, the C# project file. And this file will contain, let's open that up as well with Notepad. It'll contain references to things like all the files that are associated with this project and any of the settings and any other metadata. Again, information in here that you certainly don't want to edit, and you don't want to accidentally make any changes to it whatsoever. But I just wanted to make you aware of it, that there's really nothing magical going on. There's just these configuration files that contain information about your project, and as you make settings on the project level, those will be saved inside of that CS project. And then finally, there's this bin folder here, and the word bin typically is short for binary, which denotes that this is where a binary version of your application will be stored. So the process of compilation, it takes your source code, and which is human readable, and it's going to convert it into a format that is machine readable or understood by a machine, your computer. And so if we were to take a look inside of this folder, we would see that there is a debug folder. And so this folder is created for us whenever we started debugging our application. It creates a temporary version of our application for debugging purposes, which we'll talk about later. If we drill into that, you'll see that there is actually an executable file and several other helper files for the purpose of debugging. We'll talk about these later. If I were to double click the hello world.exe, it actually executes our application. All right, and so, you know, compiling your code into a working application is the end goal, but I don't want to talk about compilation just too much yet, or about creating a debug version versus a release version of your .NET assembly, of your compiled code. I think you're going to get a better appreciation for those ideas after we get past some more of the basics. So what I want to do is just stop our conversation about the bin directory right now, and we'll come back to that a little bit later. But you're doing great. Let's continue on. We'll start learning more C# now that we have some of these tangential topics out of the way. Or I'll see you in the next lesson. Thanks. Hi, I'm Bob Taybor with Developer University. For more of my videos for beginners, please visit me at devu.com. Now in this lesson, I want to get back into talking about C#, the syntax, and we're going to talk about declaring variables, how to choose the right data type for your new variable, and then also how to initialize variables with values. So to begin, let's take a look on screen. If you've ever taken an algebra course, hopefully you've seen something like this where you're asked to solve for the value of x. And hopefully without a lot of thought, you're able to see that x equals 7, right? So using that same thought process, take a look at this little snippet of code on screen. X equals 7, y equals x plus 3, and then we're going to do a console.write line with the value of y. And hopefully you look at it for a moment using your existing knowledge of algebra, and you think to yourself, well, then it's going to output the value of 10 to a console window, right? Exactly. And so my point is that C#, first of all, is human readable. It's got a few things that might be a little foreign to you, like the semicolon at the end of the line. However, for the most part, I'm willing to bet that as we go through this series of lessons, you'll be able to understand what the code is doing, for the most part, even before I explain it to you. So it's really not that hard. And then secondly, it's probably very similar to things that you've done in the past, like working with math and algebra and things of that nature. And so if we're looking at the C# code, the x and the y in this context are referred to as variables. And a variable is simply, under the hood, a bucket, I guess you could call it, in the computer's memory. And you put things in buckets and you dump things out of buckets, right? And so we can put values into a given bucket in the computer's memory, and we can retrieve the value out of that bucket. We can even replace what's in the bucket with something different, right? And so that is what you use a variable for. And so this particular situation that we see on screen, these buckets are just holding numeric values. However, we could create buckets that are just the right size for almost any type of information, whether it be individual alphanumeric characters or strings of characters, strings of alphanumeric characters, like even entire sentences and paragraphs and even books. We could also create buckets that are just the right size for dates and times, buckets that are just the right size for really, really, really massive numbers, or even create buckets that are just the right size for numbers that have a lot of values after a decimal point. Now, in this case, what we would expect to see here is that these two buckets, the bucket that's labeled X and the bucket that's labeled Y, would hold numeric values because we want to add numeric values together, right? And so we know that, but how do we express that intent in C#? The instructions that we write in C# will ultimately, after a compilation step, they will ultimately be executed by the .NET runtime that we learned about in a previous lesson. And part of its responsibilities are to make sure to allocate memory for our variables in memory to hold the right kind of data. So here we have two data items, an X and a Y, and we have to tell the runtime that we want to allocate some space in memory that's sufficiently large enough to hold numeric data like the type of data that we want to work with here in our application. But how do we do that? Well, that's the topic of this lesson. So to get started, what we want to do is create a new project. And here again, I'm going to go to File, New Project. We will go to the New Project dialog and make sure we select the Console Application Project Template. And here we're going to rename this and call this project Variables. And then click the OK button. And Visual Studio goes to work, uses that template, and creates a new solution with a project. And as you can see on screen, here we are back in our familiar program.cs. Obviously, we want to work inside of our static void main in between the opening and the closing curly brace, just like we learned about in our previous lesson. All right. So before we get started, there's one big takeaway from this lesson, and that is that a variable is simply a bucket in memory that you can put data into and retrieve data out of. But we have to tell the compiler, we have to tell the .NET runtime what size of buckets that we want to create. So we have to declare our variables. We have to create those buckets and then give them some label that we can refer to them with from that point on. Now, before we get started here typing some code, all the same rules apply in this video that applied previously. So you have to type the code exactly the way that I type it. Take the time, develop the skill of identifying differences between even small differences, a different in capitalization or in spacing or the various special punctuation marks that we use while we're writing code. Develop that skill to identify the differences between what I write on screen and what you're writing in your copy of Visual Studio. All right, and if you see a little red squiggly line, you already know that there's going to be a problem there, right? So that gives you the clue necessary to go and focus either on that exact character or in that vicinity and use your detective skills to figure out what it is that went wrong. Okay, so now let's go ahead and we're going to create two buckets, two variables, and define them in such a way that they're going to hold numeric values. So we'll start with int x and int y, and it's as simple as that. So here, to borrow the explanation that we used earlier, we are asking the .NET runtime to allocate space in our computer's memory sufficiently large enough to hold numeric values. Now we're asking it to create these two buckets, and eventually we're going to put values into them and read values out of them, but at this point we're just declaring their existence and saying here's what we need to work with. And then after we've declared them, after we've created them in this manner, then we can begin to work with them and assign values, retrieve values from them. But most importantly here, I'm telling the computer that I want to assign integer values into those variables. And an integer is really just a mathematical term that refers to a whole number that's within a certain range. So no values after the decimal point. And as far as C# is concerned, the values have to be between a negative 2,147,000,000 and a positive 2,147,000,000. That's the size of the bucket that we have to work with. If you need to work with much larger numbers, then the int data type is not the correct data type for you. There are other data types to choose from, and we'll learn about some of those a little bit later. If we needed to work with like money values where you have dollars and cents or pounds and pence, then the integer is not the right data type to work with. Okay. Let's continue in our application, and this is basically just to continue what we did in Notepad a few moments ago. So x equals 7, y equals x plus 3, and then we want to do a console.writeLine with the value of y. And then remember, we want to do a console.readLine so we can actually see it on screen without it just flashing and going away immediately. So let's run the application and make sure we get the value that we're expecting. And hopefully you got the value 10 in your copy of Visual Studio just like I got in mine. If not, again, make sure you double check your work against mine. All right, so after we declared the variables in lines 13 and 14, then in lines 16 and 17, I'm doing assignment using the equal sign. Now in this case, we don't really call it the equal sign, we call it the assignment operator. We'll learn about operators in the next couple of lessons. This particular operator, the equal sign, means take whatever is on the right-hand side and assign that into whatever's on the left-hand side. So we're going to say, give me the value of 7 and assign that to our variable, our bucket named x. And the same thing would be true here with y. We're assigning a value into the bucket named y, but we have to do something interesting here. We have to actually retrieve the value of x from memory. So what was x again? Where's that bucket again? Oh, there's the bucket. Dump the value of the bucket out. You're holding the value 7. Add that to 3, and then we assign that to the value of y. Now here we're retrieving the value of y, saying, okay, give me the bucket with y in it, and you dump it out into the console.writeLine, which we know then will print that to screen. And that's essentially assignment and retrieval of variables. Okay, so this is a very simple case. What I want to do now is comment out this code. If I were to begin commenting out the code like we learned about in a previous lesson, I could use the 2 forward slashes. I'm going to show you a different method in just a moment, but notice when I do that, something interesting happens. I commented out the declaration for the variable named x. And when I do that, notice I get these little red squiggly lines underneath x's. And if I hold my mouse cursor there, it says the name x doesn't exist in the current context. And we might say, well, there it is right there. It's in our code comment. But remember, we're telling the C# compiler and ultimately the .NET runtime to ignore that instruction. So the compiler is looking at our code and saying, I have no idea what you're talking about x. I've never heard of x before. I don't know what you want me to do with x. And so it raises the red flag and say, I can't continue on under these conditions. You have to give me more information. Obviously, we can fix it by removing the code comments. All right. Now, what I want to do is comment out several lines of code. And instead of just doing 2 forward slashes in front of every line, which can be laborious, I'm going to comment out multiple lines at the same time using a forward slash and a star character over the number 8 on your keyboard to begin a lengthy comment, and then right here before that read line, actually let's go ahead and keep it all together. After that, I'm going to do a star forward slash. And so now we're going to type another code example beneath that. All right, this one will be a little bit more interesting. Follow along. Pause the video if you need to catch up with me. I'm going to try and type fast just to save time. All right, and before I forget, let's go File, Save All. Great. Now, let's begin here at the top. You can see that this is a different style application with some different commands or different uses of commands that we're familiar with. So we're just going to play a little name game, and we're going to ask, what is your name? And we output type your first name. Now notice in the first case I'm using a right line, which will print what is your name to screen and then use a line feed character to go to the next line. However, I'm using yet a third method from the console object, the console class, which we'll talk about classes and methods later. But this method is different than write line. This will just write out the statement, type your first name, whatever's in between our double quotes there, and it won't go to the next line. It'll just wait there on that line. And then what we're going to do is create a new variable using a different data type, a string data type. So we're not interested in individual alphanumeric characters, so A through Z, 1 through 0, and the special characters. We're interested in a string of them, or a collection of those characters. So not just the individual character B, the individual character O, and the individual character B. We're interested them as a string or a collection as Bob, B-O-B. Okay, so that's what we're declaring a bucket in the computer's memory sufficiently large enough to hold a string of characters, however long that it is. All right, and then what I'm doing is calling our console.readLine method that we're already familiar with, but there's a twist on this. Up to this point, we said we're using the read line method in order to stop the execution of the application, to wait for the user to hit the enter key on their keyboard, then to resume. However, now we're using it for its real intent, which is to retrieve data from the end user. So in this case, we're asking a question, what's your name? The user types it in and hits enter, and then whatever they typed in is assigned using the assignment operator to the variable we created called first name. All right? Hopefully that makes sense. Now we're going to create a second variable of type string called my last name. We're going to do the same thing here, console.write, and then we're going to allow the user to type in their last name. And then whatever they type in when they hit enter on their the enter key on their keyboard will be saved or assigned to the variable called my last name. Now that we've done assignment to my first name and my last name, I'm merely going to concatenate the values together. So let me point something out. There's several things we need to talk about here. Notice here we were doing actual math where we were adding values together. This is the arithmetic or arithmetic operator. We're basically adding things together, right? Here we're kind of adding things together, but the connotation is different. We're not adding hello and Bob and Taybor with some spaces in there. From a mathematical perspective, we're concatenating strings of characters together to make one really long string. So it's the same operator, but it's used in two slightly different contexts. Kind of does the same thing, but we need to understand that there's a fundamental difference in how operators interact with different data types. Okay, you'll see why this is important as we continue on through this course. But at the very end here, we're expecting to see hello, comma, space, Bob, space. Notice that I have in here a additional double quote with a space in between to give some spacing between the first name and the last name, and then obviously my last name here. We'll get that one more line of code to write because we need to do another read line so we can see the value on screen. Let's run the application, and we have some things we want to talk about here. Okay, so what is your name? Type first name, Bob, enter. Type your last name, Taybor, enter. Hello, Bob Taybor. Awesome. Okay, so very simple application, but hopefully now we're pushing the envelope a little bit more, learning a little bit more about additional data types that we can use for our variables, and learning about assignment, that it works with all kinds of variables, and then also learning about operators that work differently with different data types. Now, before we get too far, in the previous example, we used merely X and Y, which we might expect to see in some mathematical context, because we're used to seeing those characters used in algebra problems. But whenever we start writing business applications or even games, we need to give our variables names that are meaningful inside of the program that we're writing. So I could have just used called this X, and then done something like this X, and then done something like this X. And you look at this and you say, I have no idea what X is supposed to do. All right? It's because we used a very vague description of the bucket in the computer's memory. Instead, you don't have to worry about keystrokes. Make it human readable. Write your code in such a way that somebody can read through it and understand exactly what the variables are doing and what the logic of the application is doing. And then also notice as I go and change some of these things back here to my first name, I used a little feature of Visual Studio that allowed me to say, now that I've changed the name of X to first name, let me rename it everywhere that I've used the word X. Did you notice I did that? I hit the control and the period on the keyboard here. Let's do that one more time. I'm going to change this back to X. Notice that I get the little light bulb here off to the left-hand side, which is quick actions, and then I hit control period on my keyboard. And now it gives me the option to rename my first name to X. And it even off to the right-hand side shows me all of these changes. This is called a refactoring. I'm changing the code just ever so slightly by renaming things to give them more meaning. In this case, I'm doing the exact opposite, but we'll come back to that. So do I want to rename every time I use the variable name, my first name, to X? Yes. So let's rename everything. Bam, just like that. All right, let's rename it one more time. So my first name, control period, and now I want to rename everything from X to my first name. And you might look at that phrase, my first name, and then again I used it down here, my last name, and you're thinking to yourself, that's a crazy naming convention. Well, it's a naming convention that's called camel casing, where you start with the first letter in a list of words that you're kind of munging together to describe a variable or something along those lines. Use a lowercase for the first letter of the first word, and then an uppercase letter for the second and subsequent words in that variable name. So ideally, it makes it human readable. I can read it fairly easily that way. All right. And at this point, I think it's important also to do something like this. I'm going to rename this to my first name, all lowercase. And remember what we said in the previous video, that C#'s a case-sensitive language. So if you were to use the wrong capitalization, then you're going to get a red squiggly line and it says my first name does not exist in the current context. Do you remember seeing that just a moment ago when we removed the declaration for X up here when we commented it out? The same thing is true here. My first name, all lowercase, is different from the bucket, the variable we define called my capital F, capital name, first name. All right. So capitalization matters. Make sure that you remember that. So in this case, let's just go ahead and change everything back correctly, and we should be good to go again. Okay, great. Now you might be saying to yourself, well, this degree of precision seems pretty difficult. I mean, how am I going to remember exactly what I named things in the past? Well, there are a couple of different tricks for them. Keeping your code methods small, and we'll talk about that later. That's one way to do it. But then the other thing is to rely on IntelliSense, which is that little code window that I told you to ignore before. It's actually pretty important. So as I start typing notice that it pops up beneath what I'm typing, the correct capitalization, correct spelling for any of the variables that I've defined up to this point that start with the letters MY. Now, at this point, what I can do is simply hit the equal sign on my keyboard, and it will type everything else out for me. So I don't have to worry about spelling. I don't have to worry about capitalization. And you may have noticed while I was typing, I was typing and then using arrow keys on my keyboard, and then you couldn't really see my fingers moving, but I wasn't typing every single keystroke. This is what allows software developers to write code very quickly. Once you get used to relying on IntelliSense, one of the tools that Visual Studio gives you in the text editor to make your typing more accurate and allow you to type much faster than maybe you normally could. Okay, we'll come back to IntelliSense later. All right. The other thing that I wanted to tell you about here, or talk about, is that we cannot define the same variable two times. So let's try this. I'm going to go and do my first name and say I want another bucket in the computer's memory with the same name, my first name, and the compiler says you can't do that. We've already got a bucket. We're going to confuse buckets in memory if we give two buckets the same name. Okay, so it says a local variable named my first name is already defined in this scope. You can't do that. Now, we could do this, but I highly recommend you don't do that because, again, my first name, all lowercase, is different than my first name with camel case. But this would cause a high degree of confusion, so never do that. Okay? Be descriptive with your variable names. Don't repeat variable names. Always stick to a naming convention and never break that rule. And if you follow those little rules, I think you'll find some of these initial issues, they'll just kind of dissipate. You won't have to worry about them. All right? Okay, so what I want to do now is take a look at this second set of code. And then not only are we in line number 29 declaring the variable, but then in line number 31, we're actually giving it a value. What if we were to rewrite this little passage of code? So I'll go ahead and comment all of this out. And I'm going to make this smaller. In fact, here's what I'm going to do. String my last name equals console.readLine. And then I will say console.writeLine type your last name. All right. Okay, so you can see that I took these two lines of code, 29 and 31, and I combined them together. And so what I'm doing here is not only declaring the variable, but then I'm initializing its value to whatever we retrieve when we call readline. So this is called initialization. And initialization is important because you want to give your variables a value as quickly as possible. This puts your variable into what's called a valid state, which will be an important idea as we learn to write applications, real applications. But also experienced developers like to write less code, and they're always looking for a convenient way to reduce the number of keystrokes that they have to type and reduce the amount of code that they have to read. And so usually you want to declare your variables as you're using them, and not declare them like some people used to do a long time ago, put them all at the very top of a given method or section of code. And so you should get into the practice of two things. Declaring your variables as you need them in the body of your code, and then secondly, if you can, give them an initialized value immediately after you declare them, like we've done here in line number 34. All right? Okay, so tell you what, let's stop right there. I think we've covered a lot of ground for one lesson, right? Let's do a quick recap and just talk about over a dozen things that we discussed. We talked about what a variable is. We talked about how to declare a variable, how to choose the correct data type. We talked about the int data type and the string data type. We talked about assigning values into variables and then retrieving values out of variables. We talked about the assignment operator. We looked at the arithmetic operator and also the string concatenation operator, which is both just the plus sign. We looked at console.write versus console.writeLine. We looked at the other life of the console.readline method, that we can actually retrieve the values that the user types in. We talked about camel casing and naming conventions for our variables. We looked at IntelliSense. We talked about how to rename things, how to refactor our code using the little quick action. Remember the little light bulb that we could make changes to by hitting Control and period on our keyboard and then using our arrow keys to make selections and to rename all uses of our variable name throughout our entire code base. We probably talked about a lot more than that as well, but let's go ahead and wrap it up here, and we'll start again in the next lesson. We'll see you there. Thanks. Hi, I'm Bob Taybor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, things are going to get a little bit more interesting. Based on user input, we're going to write logic to execute either one block of code or another block of code. So when I use the term logic, I mean that we're going to make a decision to execute some code based on some condition. That could be the user's input from the keyboard, maybe the state of the computer system itself, maybe some other data that we have access to or available to us. But somehow we're going to make a decision on whether to branch out and execute this code or execute this other code, all right? And so let's begin the way that we normally do by creating a new project, and I'm going to go File, New, Project. Make sure to choose a console application, C# console application, and we'll call this project Decisions and click OK. And what I want to do is we're going to create a little game, and we're going to do it right here in static void main. And I'm going to go ahead and start typing. You can pause to catch up with me. Alrighty, so hopefully most of this will make sense. Let's go ahead and run the application. And here we're going to play Bob's Big Giveaway, and we can choose a door. What's behind door 1, 2, or 3? I'm going to choose what's behind door number 1, and it said, hey, you want a new car. Awesome. Let's play again. I'd like to win something else. And so now we can type in the number 2, and, well, nothing really happens at all. I'm going to hit enter again on my keyboard, and the application just ends. We can try the same thing for 3, but I suspect the same thing will happen with number 2, and I can just type something randomly, and again, nothing really happens here. But let's start at the basics and talk about this if statement that we've created here, which is really the purpose of this lesson in the first place. The if statement is called a decision statement because we will decide whether to execute any of the code inside of this inner code block based on this evaluation that we're going to do after the if keyword. So in this case, what we're doing is evaluating whatever the user typed in, and we're gathering that from the console.readline like we learned in the previous lesson. So the user typed something in, they hit enter. We got that now in the user value variable, and we want to perform an evaluation to see if what the user typed in is equal to this literal string number 1. All right, and so here's where hopefully I want to call your attention to this. You can see that I'm using 2 equal signs next to each other. So we already learned previously that a single equal sign is actually an assignment operator. We're assigning the value of whatever the user typed in this case, in the console.readline, to the variable user value using this assignment operator. But whenever you use 2 equal signs next to each other, you're going to do an evaluation for true or false. So whatever's inside of this opening and closing parentheses, we're going to perform an evaluation. Is user value in fact equal to the number 1, or rather the string character 1, or is it not equal to the string character 1? It can only be true or false. All right, and so based on that, if whatever the evaluation of that expression is, if it turns out to be true, then and only then will we perform the code defined in the code block immediately after that if statement. If that's not true, if this turns out to be a false statement, then we'll just ignore whatever's inside of this code block and we'll continue the execution of our application to line 23 and then beyond. All right, so that's how it works. But I tell you what, this isn't a very interesting example because obviously here we have no prize for door 2 or door 3. And then what happens if somebody just types in 4, 5, 6 or ASDF or whatever on the keyboard? We need to account for all of those scenarios in our application. So let me continue typing in some code here, and you can again pause the video if you need to follow along. But we'll start by using an else if statement right below our code block for the if statement. Okay, so here we go. All right, well, let's stop right there for the moment. And you can see that in order to evaluate additional conditions, I can use the else if statements. In fact, I have 2 of them here. So if this first evaluation is not true, then we'll continue on and do a second and a third and maybe a fourth and fifth, how many other evaluations you want to do. However, if this is true, then we'll no longer run any of these additional checks. We'll just continue on to line number 33. The same is true here. If this is not true, then we're going to evaluate this next expression. If this is true and we execute the the code inside of the code block immediately following it, then we'll just go ahead and skip over this last else if statement and continue on to line number 33. All right. So if we were to run the application, let's go ahead and just quickly run through scenario number 2. Hey, we want a boat. And scenario number 3, which obviously would allow us to win a cat, but then we still haven't accounted for the situation where we type in for or anything else like the word or just random letters on the keyboard. Nothing really happens in those situations. What we really need is what I would call a catch-all case. And so to do that, we'll just create an else statement at the very end of our if-else-if construct. And so here what we'll do is just set string message equals sorry, we didn't understand. And then console dot write line message. All right. So now we're catching every other case possible no matter what the user types in. So let's go ahead and run the application. Again, I'll just type in some junk from the keyboard, hit enter, and it says, sorry, we didn't understand, and we continue on. Okay? So that's how an if decision statement works. It also has these optional parts of the else if and the else statements for either additional evaluations or what I call the catch-all, just in case none of the conditions are true. Okay. Now, there's a couple of things about this, and we're going to continue on and talk about one other type of decision operator that we can use, a conditional operator. But before we do that, here's an opportunity to clean up our code. Let's look for areas where we've essentially got the same code repeated over and over and over again. And I can see a couple of instances where this is true. The first would be where we have this console.writeLine message. You see we've repeated that in line 20, 25, 30, and 35. Wouldn't it be great to keep our code a little smaller and only use that once at the very end of our evaluation, like put it right there, outside of the if, else decision statements. All right. So let's go ahead and just remove those from there completely. All right. But when we do that, notice that I'm getting a red squiggly line under the word message. The name message doesn't exist in the current context. All right, so we're going to talk about scope and declaring variables inside of certain scopes in a little bit, but just to kind of lead up to that conversation, essentially when we've defined a variable inside of an inner scope, it's not available outside of that scope. In other words, if we define a variable inside of a code block, inside of the curly braces, it's only available inside of those curly braces, not available outside of those curly braces. So what we'll have to do is define that message variable outside of our if statements so that it's accessible to all of the inner code blocks as well as our console.writeLine message here in line number 35. So it's a very simple fix. We'll just do this string message equals, and then we'll just set it to an empty string to begin with. All right, so now you'll see a different message, a red squiggly line, but we've seen this before. You can't define the same variable twice, even if it's in an inner scope. So what we'll do is just say, instead of defining the variable message there, we'll just set our existing string variable called message to the value like so. Okay, great. So now our application should run. We've eliminated a lot of code. And admittedly, I created a straw man here. I wrote more code than I needed to, but I wanted to illustrate this point. So again, if we were to run the application, it works correctly. But there's one other change that we can make. Code blocks inside of, as we're using them inside of if, else if, and else statements, if there's not more than one line of code to execute, then we don't even need to use the curly braces. In other words, since there's just one line of code here underneath my if statement, I can just remove it and make it small like that, real compact. Same is true here, and same is true here. Now, in this case, maybe just to kind of illustrate why you would need the open and closing curly braces, if I were to do this, message equals message plus you lose, like so, and I'll even add a little space here to make it look correct. Let's go ahead and test that else case just real quick. And I'll type anything in there and hit enter. And says, sorry, we didn't understand, you lose. Notice that we were able to concatenate two strings together. I did it on two separate lines, don't really need to. But if I were to attempt to remove the opening and closing curly braces there, we're going to get a very different result when we run our application. So for example, if I hit 3, notice that you won a new cat, you lose. Wait, what? How? Why did that happen? You won a new cat, but you lose. Well, there is no such thing as a free cat, but at any rate, it's because what it's really seeing is this, like that. All right. If we want these two to be evaluated together inside the same code block, we have to include them in the same code block. Otherwise, this being outside of that code block will execute no matter which of these if or else if conditions are true. All right, so let's go ahead and put that back in there just to kind of illustrate that idea. In fact, if we were to do something like this, I can even make this a little bit smaller. Let's comment that out. And I'm going to show you a new operator, which is just this. Okay. So now instead of going message equals message plus you lose, essentially I'm saying give me whatever's in the variable message, concatenate on the word you lose, and then assign that back into the variable message. That's what I did here. I just do it all in one step right there where I say whatever's in the variable message, on the end of that concatenate you lose. So this is the assignment and concatenation operator kind of combined into one. Okay, just a little shortcut there. All right, so now let's do this. Let's talk about another style of decision statements. It's actually an operator called the conditional operator, and this works well if you have an if or else kind of scenario and you don't have multiple items to evaluate like we did here. So I'm going to copy some code from lines 14 and 15, whoops, yeah, and line 16 too. Let's just copy all of those and we're going to paste them down below our commented area. All right, and then what I'm going to do is this. Or how about this? We'll do this a little bit different this time. Okay, there we go. Now I've written a lot of extra code that I need to. I'm going to show you how to shorten this up in just a moment. All right, so here the key to this is this little evaluation that I'm doing on line number 42. Remember that we're going to evaluate anything in between of the parentheses whenever we see the double equal sign. That means we're doing an evaluation. Is the user value that they typed in and submitted through the previous line of code, line number 40, is it equal to the literal value 1? if that is true, if this equates to true, then what we want to do is everything after the question mark, we're going to take that value and assign it to our new variable called message. All right, so if the user types in 1, we'll find the word boat, the literal string boat, and we'll assign it to the variable message. However, if this equates to false, so they type in something different, then anything after the colon will be taken and assigned to the variable message, and we'll use that below. So let's go ahead and run the application. We'll run it twice. We can choose a door, and if they choose door number 1, they win a boat. However, if we run the application a second time and we choose anything else, then you'll only win a strand of lint. Again, this is only useful in a if-else condition, not when you have multiple conditions to evaluate. All right, now let's address this last little part here, because I can shorten this up considerably. Notice in order to get it all to print out on one line, I only use console.write. And so then I typed out the literal string, and then I have a second line where I'm actually then printing out the actual message from line 42, and then finally to add a period at the end, I'm having to do yet another console.write statement in order to add a period. Okay, I can shorten all that up in one line of code. Watch how I do this. In fact, let's go ahead and I'll comment out these lines individually like so, and then I'm going to use a replacement character inside of the console.write line in order to shorten this up a little bit. So we'll use a write line instead, and we'll put U1A, and then I'm going to use what I call a replacement code. So a replacement code of 0, and then after I give it that literal string, I'm going to use a comma, and then give it the actual message variable that I want. Whatever's inside of this, I want it replaced in here. Okay, so eliminate that, the curly braces with the 0, and put the message variable value inside of there. So let's run the application again just to see this working. I'm going to type the number 1 and get the same result. All right. Now, what if we wanted to expand on this idea here? Let me comment that out. And what if I wanted it to replace 2 values inside of that console.write line string? So let's do something like this. You entered, and then we'll go 0. Therefore, you won a. All right. And so in this case, after the comma, I'm going to enter the user value and then the message here. Let's make sure you can see that. All right, hopefully you can see that all on screen at one time. So I need to do one little thing here, is change that to a 1. All right, so this says take the first item. So in software development, typically you don't start with the number 1, you start with the number 0. I don't know. So we're going to see this pop up again and again. So the first item in the list will be at element 0. The second item in the list will always be at element 1, and so on. All right, so the very first item, this will be matched and replaced by the very first item in that comma delimited list of input parameters after the literal string, that little template that we've created for ourselves. Then here we're going to do a second replacement and replace that with whatever's inside of the message variable. So when we run the application, and we type in the number 1, said you entered 1, therefore you won a boat. Awesome. All right. Okay, so that's enough for one lesson. Hopefully you've learned a couple of important things in this lesson. First of all, we talked about the if decision statement as well as the else if and the else, and how to do a comparison, an evaluation between 2 values to determine true or false. If we're using an if statement and we're doing that evaluation, then anything, the code that is in the code block below it will get executed. If that evaluation is true. If it's not, it'll either drop down to a second and subsequent evaluation, or even do a catch-all in the else statement. We talked about using curly braces for a code block versus when you don't need them. We talked about keeping your code nice and tidy and small. We talked about declaring variables inside of scope and inner scope and outer scope as defined by our curly braces for code blocks. We talked about the conditional operators, being able to all in one line do a check for true or false, and if it's true, assign one value versus a different value to a new variable. We talked about format codes inside of literal strings for our console.write line and how to replace those replacement codes with variable values that we then also pass in our console.write line statement, like you see here at the very bottom in line number 49. Okay, so again, covered a lot of ground. Hopefully this all makes sense. If not, rewatch the video. Just watch those portions that didn't make sense. Make sure you're typing in the code yourself so that you can come to some of these epiphanies as you're typing. Okay, all right, we'll pick it up in the next lesson. See you there. Thanks. Hi, I'm Bob Taybor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, I want to spend a bit more time talking about some smaller syntax elements of the C# language that you need to master to understand how a properly formed line of code is constructed in C#. And in one of the previous lessons, almost like the first lesson, I said something to the effect that just like you use a period or question mark or exclamation mark at the end of a sentence in English to complete a thought, you also use a semicolon at the end of a line of code in C# to denote a complete thought. And kind of to extend that analogy a little bit, I may have briefly referred to C# syntax as having nouns and verbs. So I want to elaborate on these sorts of things and clarify what I mean by that in this lesson. So I'm going to talk about the basic building blocks and I guess you could say parsing the parts of speech in C#. So let's start off at the beginning. Statements are what you call complete thoughts in C#, typically one line of code. A statement is made up of one or more expressions. And expressions are made up of one or more operators and operands. So we've seen a number of statements and expressions and operators and operands already, whether you realized it or not. So as we're taking a look at some of the previous work that we've done, here I've got the variables project from a previous lesson opened up. And so, for example, you can see that essentially each line of code is a statement. Each of them are made up of one or more expressions. So here, for example, is an example expression. This happens to be a variable declaration statement made up of a operator, which in this case is a keyword int for the data type integer, and then an operand, in this case a variable name. We also use another operator, the semicolon, for the end of the line of code. Another example would be here where we have an assignment where we're actually calling a method. So here is an operand. It is the name of a class. And we're using the open close parentheses. Remember, these are operators. This is the method invocation operator. Then we're using another operator here, the assignment operator, to assign this expression, the value of this expression, to another operand, the name of a variable that we created. All right. So if we were to look through the code, we could continue to kind of parse out and understand what makes up operands, operators, expressions, and then entire code statements. Now, operands are similar to nouns. They are things like objects and classes and variables and even literal values. These are the subject, I guess you could say, of your statement of code. And they're pretty easy to remember because typically you give them names, you define the values yourself, and so on. Now, operators are similar to verbs. They are things like the addition operator or the string concatenation operator. These are things that act on the operands in order to perform some action. And typically you're going to use the built-in operators, although you could create your own operators, kind of a little bit of an advanced topic, but there are actually quite a few built-in operators, and you're going to need to memorize many of them. That's how you come to express yourself in C#. Now, fortunately, as you start out, you probably only need to know a handful to be productive. And so what I want to do in this lesson is to focus on a few that I think you're going to use probably 90% of the time as you begin learning, and you can obviously add to that list as we continue. So I'm going to actually present these in a rapid-fire fashion. I've created a very nonsensical application. You can open this up, download it from wherever you're currently watching this video or wherever you originally downloaded it from. I called this project Operators Expression Statements, and the application itself does absolutely nothing meaningful at all, okay? And so all it really does is kind of show you some examples of the various operators and expressions that you'll come across whenever you're working in C#. All right, so at the very outset here, you can see that I have a variable declaration. We talked about this already. I did something a little bit different this time, where I've declared several variables all up front as integers. So X, Y, A, and B are all defined as integers. Just wanted to show you something a little bit different there. By separating them with commas, it's an easy way to just to declare several variables of the same type all on one line of code. Now, I typically don't recommend this, but you might see this around in use in books and on the internet. All right, so next up, assignment operator. We've already seen the equal sign at work in that capacity. Note here in line number 22 and following that there are actually many different mathematical operators. We're only looking at the most basic ones, but there are also some advanced ones as well. But here we have addition and subtraction, multiplication and division. And as I demonstrate here, you can use parentheses to actually change the order of operations. So these are not, in this particular situation, the parenthesis is not a method invocation operator. It's actually how you would typically use it in an algebraic or mathematical sense. You would use it in order to specify the order of operations. So perform this expression first, then this expression, and then take the result of those two and multiply them together in that third expression, and then assign them to the value of x. Okay. And then there are operators that are used to evaluate. We've already talked about the equality operator, where we're using two equal signs next to each other to make sure that these two items are in fact equal. Here again, we're using parentheses in yet a different capacity to define the boundaries of our expression that will either equate to true or false. So x equals y is either true or false. We can use greater than, we can use the less than operator, we can use greater than or equal to, less than or equal to. All of these, again, should produce a true or false result. There are also two conditional operators that can be used to expand or enhance an evaluation, and they can be combined together multiple times, as I say here in the comments. So I could ensure that both x is greater than y is true and a is greater than b is true by using the logical AND operator. There's also an OR operator to say either x has to be greater than y or a has to be greater than b in order for this outermost expression to be true. All right, so here's the logical OR, two pipe characters next to each other. All right. So, and then I guess we've already talked about that inline conditional operator where we have some item that's being evaluated, and then if it's true, then we'll take the first value, and if it's false, then we'll take the second value. And in this case, we're assigning either car or boat into this message variable's value. And then also wanted to talk about member access and method invocation. We're going to talk about object-oriented programming quite a bit later on in this series of lessons, but we've already said how the console was a class, and classes are containers, for a lack of a more robust definition, for methods, and the way that you access a member method of a class or an object is by using the dot or the period. That is the member accessor operator. Furthermore, we talked about the method invocation operator. Here we are invoking a method called writeLine by using the opening and closing parentheses. And in this particular case, we're passing in an input parameter. Again, we want to hold off and talk about input parameters and methods a little bit later. But as you can see, here's a number of different operators, and these are just what I would call a very baseline set. You need to memorize these so that you can express the most basic of C# commands and understand exactly what it is that you're trying to do. It's not an exhaustive list by any stretch of the imagination, but you will probably need these about 90-95% of the time. And then you can expand your vocabulary of other operators and keywords over time. So in each of these cases that we just looked at, an expression is made up of a combination of operands, which are things like the literal strings and variables and objects like the console class itself, and operators. So things like the addition operator, string concatenation operator, equality, assignment operators, and so on. And you use expressions then to form complete thoughts, statements in C#, which are how the actions or the instructions of an application are expressed to the compiler and ultimately to the .NET runtime, which executes your application. All right. So why am I telling you all of this? Why go through this little English lesson, parsing out the different parts of speech if you've ever had to take an English class? Well, it will help you to understand why this is not a valid statement in C#. You can't just type x plus y and then give it a end-of-line character and expect it to do anything. The C# compiler will look at that and say, what are you trying to accomplish here? Have you lost your mind? What do you want me to do with all this? So fortunately, in situations like these, as you can see, Visual Studio can catch these sorts of syntactical mistakes even before you attempt to run the application. And if we were to hover our mouse cursor over the visual guidance here, the red squiggly line, you can see that the fundamental problem with this line of code is that only assignment, call, increment, decrement, and new object expressions can be used as a statement. So what's the problem here? Well, this is not a properly formed statement. We're not assigning, calling, incrementing, decrementing, or creating new object expressions. We're not formulating a complete thought, a good sentence. I mean, I could create an English sentence like this: the red ball, period. And you would say, the red ball does what? Who has the red ball? Okay. We can understand that just because you use words doesn't mean you're creating a complete thought or expression inside of the English language. Same thing is true with C#. All right, that's all I'm trying to say here. So for beginners, understand that there's a proper syntax, just like there's a proper grammar in the English language. Understanding this is really a big step towards solving your own problems whenever you're phrasing C# instructions that the C# compiler will understand and accept and ultimately compile into code that will be run by the .NET framework. So here, let's recap what we talked about in this lesson. First of all, statements are complete instructions in C#. They consist of expressions. And a statement is like a sentence in the English language, and expressions are composed of things like nouns and verbs, in other words, operators and operands. The operands are things like nouns. They're the subject or what we want to do something with. And then there are the operators, which are more like the verbs. These will act on the nouns to perform some action. We said that operands are like variables and classes, literal strings. These are things that we get to name ourselves. They give the meaning to our application, whereas operators are, for the most part, built into the language, and we have to memorize them. And so to start off, you might use something like what I've given you here in the form of a project for a cheat sheet. But I think you might just be able to walk your way through and rationalize your way through now that you understand that there's a proper way to format a line of code. You might say, okay, what do I need to do here? And you might be able to reason your way through the operands and the operators. I'm going to need a variable to contain some values, and so once I have created that variable in memory, now I'm going to need to assign it to something. Now, how am I going to get to that something? I'm going to need to take another variable and this literal value, and I'm going to need to add them together with an operator, and hopefully you get the idea there. Okay, so I hope that this was a useful exercise. I think it's useful for beginners to understand that there are syntax rules, and they're not so unlike what you're already familiar with. Maybe they look a little bit different than your typical English sentence, but they still have to make sense, and they have to perform an action, they have to do something. And so when you see errors, sometimes it's because you type something incorrectly, and then sometimes it's you may not be using the right forms of speech, in a sense, in order to express that complete thought in C#. Okay, so let's pick it up in the next lesson. We'll see you there. Thanks. Hi, I'm Bob Taybor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, we're going to focus on iteration statements, a specific iteration statement called the for iteration statement. Sometimes you're going to need to loop or iterate through a sequence of things to find something that you're looking for, to find a successful match. And actually, you're going to do this sort of data manipulation more than you realize. So you'll have to trust me that this is a very important tool in your toolbox that you're building. So as you can see, I've already taken the liberty of creating our project. I called it for iteration. Pause the video, go through the steps that you already know how to perform to create a new project, new console window project, and catch up with me. I'm going to begin to add some code here on line 13 in just a moment. Now, the syntax that we're going to write here in just a moment is possibly the most cryptic of anything that you've seen yet. And I'm going to be completely honest. Sometimes I get things a little bit mixed up myself, but don't worry. After we've struggled through it once or twice, I'm going to share the little secret that I use to get it perfect the first time, every time. All right. So having warned you about the complexity of the syntax, I'm still betting that you could figure it out and read it even before we actually attempt to run the application, even before I take the time to explain what each little bit of the application is doing. So let me write it out here, and then we'll try that. Okay, very simple, at least very compact section of code here. Actually, you need one more line of code, right? Console.readline. There we go. Now we're ready for action. Okay, so what do you think that this code does? Okay, got a theory in mind? Well, let's go ahead and run the application and see if your theory is true. All right, you can see that we have a list of numbers from 0 to 9, and then we can hit enter to continue on. So we're using C# to execute this little block of code right here until a certain condition is true, at which point we will stop executing that line of code and continue on to line number 17. So this for statement says that we should begin by declaring a variable. We're going to call it I. We could call it anything we want to. And we're going to initialize its value to 0. Now, as long as I is less than 10, we're going to continue to execute the code below it in our code block defined by our curly braces. Each time that we iterate through, we'll increment the value of I by 1. So this little bit right here is probably the part that you probably wouldn't completely understand unless I explain it to you. Remember how we use the plus equal sign in order to automatically take the value of message and add something to the end of it and then assign it back to the value of message? Remember that a couple lessons ago? We're essentially doing that here. This is the increment operator. So we're going to increment the value of I by 1. All right, so again, we're going to initialize and declare a variable and initialize the value. Then as long as this middle part is true, we'll execute the code below. And once we finish executing, then we will increment the value of I and then do that evaluation one more time. If it's still true, then we'll execute this code again. We'll increment I. If this is still true, we'll increment it again, and so on. All right, so that's how it works. Yes, this is cryptic syntax, but if you can just separate the 3 parts in your mind by remembering that there's semicolons that separate them, that can help. You know you're going to need to start off with some counter of some sort. You're going to need a condition, and then you're going to need an incrementer at the end. Okay. And again, I'll show you a way to remember this so you never forget it. But before we do that, let me comment out this line of code and give you a variation on this idea. This will be fun. So here we go. So you can see that I simply added inside of our code block for the for iteration statement another if statement with its own code block inside of it. And here we're checking the current value of I. And once we find something we're looking for where I is equal to 7, then what? We'll perform this code. What does this code do? Well, this part's obvious, but this break statement may not be so obvious. You use the break to bust out of or break out of the for iterations. So we're going to make it to the value where I is 7, and then we're going to hit the break statement, and then we'll continue on to line number 23. Let's see it in action. It's not going to look all that exciting, but I got an idea. All right, it found 7, and it pretty much finished, right? I have an idea. Why don't we watch this execute line by line? And to do that, we'll use the debugging tools inside of Visual Studio, which we have not even talked about up to this point, and yet is probably one of the most important features of using Visual Studio as opposed to just using a text editor and a command line compiler. To make this work, what I'm going to do is actually set a breakpoint here on this line of code. Now, how did I do that? I just went to this leftmost column and I clicked in the column, in that gray column, and it created a little red dot, and off to the right-hand side, you see that that whole line of code is outlined in red. Now, there are, truth be told, a number of different ways to set a breakpoint. Probably the easiest way to do it is what I just showed you, but there's also keyboard shortcuts and there's menu options as well. So for example, with my blinking cursor on line number 16, I'll go to the debug window and I'll select toggle breakpoint. If we look over to the right hand side, you can also see that the F9 key will accomplish the same thing. Great. All right, so now let's go ahead and run the application and see what happens. All right, so immediately the application pops up, but before anything can be printed out to the console window, notice that we have paused the execution of our code, and we're paused right here on this breakpoint. Now at this point, what I can do is I can do a lot of cool things. First of all, I can see what my local variables values are currently. I can also change the value of those variables. I can monitor those values. I can change which line of code will get executed next, and a bunch of other things. Now, this is not a series on debugging. I could easily spend an hour showing you a lot of cool little features. However, what I do want to do is call your attention to this little window at the bottom. Currently, right now, we're in what's called debug time. And with the application execution pause on this line of code, the next line of code that's going to execute is that line right there that's highlighted in yellow. I can look at these little windows like this locals window, for example. And you can see that the locals window will contain any variables that are currently in scope at the moment. So obviously args is something that we haven't talked about yet. Let's ignore that one. But what I want to focus on is the value of I. Currently its value is 0. How do I know that? Because I'm looking here in the value column. I can also see what the data type of I is. It's an integer. All right. If I were to hover my mouse cursor over I, you can see I'd be able to see it there as well. And if I were to go and pin down that value, I'd be able to monitor it as well in this little helper window. In fact, I can kind of drag it around here. Now watch what happens. Let me readjust some things here. I'm going to step through this line of code. Now there's a couple of different ways I can step through the code. I'm going to recommend that we only talk about step over for right now. When we learn about methods, we can step into and step out of, but for right now, this middle button right here, the step over or the F10 key on your keyboard is what we want. So I'm going to click it once and notice that we jumped from line number 16 to line number 22. Why was that? Well, the reason was because I was not equal to 7, so we didn't execute the code inside of the code blocks underneath the if statement, and we jumped to the end of the 4 code block. Now let's continue just to step through this. You're going to see that we'll increment I by 1. Now when we do that, notice what happened. The value of I changed from 0 to 1, and that change is indicated by a change in color. Whenever you see the color red, that means something changed in the previous line execution. The value of that variable changed from some other value now to the value of 1. We can also see this in this little mini window right here as well, how it is now turned to the color red. Now that we've incremented, we're going to do the next check to see, is I still less than 10? And here we're going to step one more time into our program. Here we're going to step and in the line 14, which opens up our code block, and we'll do another assessment. Is I currently the value of 1 equal to 7? No. So we'll jump out of that if block and continue on. And we can just continue through this exercise until we reach where I is equal to 7. Now, truth be told, I don't have to keep hitting the step over button. I can just use this continue button, and this will just keep bringing me right back to the breakpoint. This basically says continue running until you hit another breakpoint. And so here at this point now, I see that my I is equal to 7, and that's what I'm checking for. So things should get interesting right now. I'm going to go back to start stepping line by line through my code, and here's where I hit the console.write line, and if I look now on screen, it actually did write that to the console window. And now I'm going to step through the next line of code and notice that it jumped out from the break statement outside to line number 23, outside of the for statement, to the console.read line. We can hit continue from that point on. Our application is still running until we hit the enter key on the keyboard, and then we've exited out. All right, very cool. Now you may have found it laborious to step through a number of times or even hit the continue button a number of times until we found just the right condition. So what we can do is make this breakpoint into a conditional breakpoint. So to do that, I'm going to hover over the little red stop sign, I guess you could call it, in the leftmost column, and I'm going to click this settings, And here, this will open up a little breakpoint settings window right in line in my code. It pushed all the other code down. Notice that it goes from line 16 here to line 17 way below it. And I'm going to add a condition. And whenever this expression, a conditional expression is true, then we'll break at that point. So in our case, when I is in fact equal to 7, then we'll break on that breakpoint. Okay? You can see that when I hit enter on my keyboard, it's saved, and now I can close this. You can see that the little icon changed from just a red stop sign to having a white plus symbol inside of it. So now when we run the application, notice that I is 7 and that I is 7, our little window here, before we even stopped into our breakpoint. And now we can continue stepping line by line through our code and continue on, right? And we got our result, and we can continue on. Okay, great. So again, I could spend an entire hour just showing you other cool little features that will help you debug your applications, but understanding how to set a breakpoint, how to run your application to a breakpoint, how to step through line by line, and then how to resume, at least resume temporarily or continue by using the continue button. Those are the key concepts in debugging, all right, using the Visual Studio Debugger. Now, let's go ahead and it'll turn off this breakpoint. From now on, what I want to do is just eliminate it. I can do that in one of two ways. To completely turn it off, I can just click on it, it'll go away. Or I can temporarily disable it by using this little icon that was next to the gear that we clicked earlier. And now you can see there's a little outline in the leftmost column and an outline around the line of code that had the breakpoint, but no longer are we actually going to break on that line. Okay, great. So let's do this. Underneath the for statement from before, but above the console.read line, I want to do what I promised you at the very outset, which was show you a foolproof way that you can get the syntax right for a for iteration statement, and truth be told, for just about anything else, by using a little secret code snippets. Okay, it's not that much of a secret, but you probably didn't know about it, did you? Okay. All right, so to do this, it's really easy. If you can remember, I need a for iteration statement. Just type in the word for. You'll see that it pops up in the IntelliSense. And if you look after the IntelliSense pops up a little message to the right there, code snippet for loop, note, tab twice to insert the for snippet. All right, let's do it. Tab, tab. Bam, and there we go. And notice that it went ahead and pretty much set it all up, although there are some parts that we're going to have to change, like, for example, the length. But I could also change, I don't have to use the value I for my iteration statement as my placeholder, as my counter, whatever you want to call it. I could call something like my value. And notice as I'm typing, and then I hit the tab key on my keyboard, it changed everywhere that was using the I variable label to my value. All right, very cool. Hitting tab also took us to the next spot in our code that we're going to need to replace, which was the length, or in other words, how many times should this for loop iterate? And I'm going to say we'll do it until my value is less than 12. Now, here again, we can use a number of different equality or inequality operators here. We don't have to use the less than. We could use the equal, or we could use the greater than, whatever makes sense for our application. But I'm going to keep it simple and leave it just like that. Once I'm done making changes, I can just hit the enter on my keyboard. There were some highlighted areas that were highlighted in gold color, kind of, that indicate that these are replacement areas. They go away, and now my mouse cursor is right between the opening and closing curly braces. And at this point, then I can continue to, create my application, right line, and then my value, like so, and then we can run our application. and we would get the following result. All right? Okay, so just to recap, it was a short lesson, but we learned a lot. Not only did we talk about 4 iteration statements and why you might want them, and we'll see them at use later, but we also talked about the debugging tools, just briefly, and how to step through our code, how to monitor the value of variables, how to use the break statement to break out of a iteration statement. We looked at code snippets and how to replace values in a code snippet in order to make it our own. All right? So we'll use some of these techniques that we learned here throughout the rest of the series. Very important video. And so let's continue on the next lesson. We'll see you there. Thanks.